Hi everyone, this is Sharan. Welcome to my channel. So this is part of the series Learning Data Science in 100 Days. So today as well as tomorrow as part of day 4 and day 5, we are going to go through the data types list, tuple, set as well as dictionary. There could be a lot of confusions for many of them who are starting with to understand why do we have all these different data types, why can't we just have one? There are some differences and distinctive characteristics for each one of them that makes each one of them special in a way. So we are going to see how to define them and how each one of them is different from one another and in what kind of use cases we can use them. Okay, to start with the list. So list should always be defined within a square bracket. So and list is like an array. So it can have integers, it can have string, or as you see, it can have a combination of a string as well as an integer. Also, it can have a string and set or maybe a dictionary and any other data types within it. So this is how we can define a list. So list is mutable, which means that it is changeable. We can add element to it, remove element to it, and we can change a particular element in a particular position. So we can do whatever operations we want on a list. And the next characteristic, list is ordered. So list is always indexed, so we can access any element based on their index. So we can define and identify the element that is like in nth position from the beginning, or maybe the nth position from the last item. And last one is a list is sortable. So now, what is tuple? Like how is it different from an list? So the first one is defining a tuple. So it must be defined within these brackets. So similar to list, a tuple can hold integer, can hold string, can hold a string as well as an array, or a string as well as an integer, any combination. The special characteristics of tuple is a tuple is immutable, which means that we can't change a tuple. Once it is defined, it stays as it is. There can't be any changes to it. And similar to list, tuple is also ordered. It is sequenced. We have index. So we can access element based on their index. And the last one is tuples are much faster than list. So that's how they have been like in Python. So tuples are always much faster than a list. So if you have an use case, if you have a number of elements which doesn't change or which shouldn't change, it's always better to define them as a tuple so that it's much faster, and then we can be sure that it is not being changed. And moving on to the next one, so is the set. So set is also very similar to list and tuple, the way they look. So it must be defined within the curly brackets. So a set can hold similarly integer or string or combination of integer as well as string. The one thing that it can't do is a set can't have any mutable element in it. So here we can see a tuple can have an array as an element within itself, whereas array or list, whereas in case of set, it can have a tuple in it which is immutable, whereas it can't have an list in it which is mutable. And the other characteristics are that set is unordered, which means that we can't access an element by an index. So there is no index. Because of that, the limitation is it can't have any duplicates. In case of list or tuple, we can add duplicates to it. They will be different because they are indexed and then their positions are different. Whereas in case of set, since it is not ordered or indexed, it can't have any duplicates. Each and every element should be distinct. And one special characteristic about set is it allows operations such as union as well as interset. So whenever you have multiple data sets, and you might have to do operations such as identifying the difference between them, like how many elements are common between them. So it's better to use them as a set. And coming to the final one is the dictionary. So dictionary is a key value pair. It is slightly different from all these three. So dictionary is also unordered, but it can be accessed using the key. So in dictionary, so we have to define it based on like using a curly brackets, But what should happen is it should have a tree, so which is the first part of the element, like here name, and then a value to it. So each for each value there should be a tree assigned to it. So it's mutable, which means that we can change it. And one special thing about dictionary is it can be accessed even though there is no index. It can be accessed using a tree. So dictionary is very similar to JSON, so which is also like a JavaScript object notation, so which is also a key value pair. So that's about the 4 major data types that is being commonly used in Python. So we will be going through each one of them in detail, like what kind of operations are allowed in each one of them. Let's go into it. We saw a brief introduction about the different data types: list, tuple, set, as well as dictionary. So in today's session, we are going to go in detail about list as well as tuple. We are going to see the various operations that can be performed on these 2 data types, what it supports, what it doesn't support, and how they both are different from each other. So let's get into it. So as you see on my screen, the basic characteristics of list as well as tuple are, so list is of course the most commonly used data type when it comes to an array like data. And the next characteristics is the list is sortable. So it is sequence type, which is ordered, which is indexed. We can access the element based on their index. It is mutable, of course, as we saw. It can change, we can add, remove, we can do whatever we want. Tuple on the other end is immutable. It's faster than list. So whenever we have a data set that doesn't change and then we want it to be faster, we should always go for tuple. And it's a sequence type, which is ordered. We can access elements based on their index. Both can of course hold, as we saw, integers, strings, or both, or any combination. So now getting into creating a list. So as you see here, what I'm doing is I'm just creating a variable called the companies, and I'm going to pass a list of values, and I'm going to check what is the data type. So what I'm doing here is, I'm including all these elements within the square bracket, so which means that this will be considered as an list. Okay, so now as you see here, so this is considered as a list. So now how do we access the elements? How do we read the elements in the list? So what we can do is we can access the elements based on their position. As you see here, what I'm going to do is companies is the name of the list, and the index always starts with 0 in Python. So when we say companies of 0, it should print the first element of the list, which is Apple. So let's see what happens. So as you see here, we are able to access the element based on their index, based on their location. What does it mean? What we can do is we can give any number to hit. So here maybe I want to try 3. Let's see what happens. So 3, let's 0, 1, 2, and 3. 3 is the last element, which is Amazon. Now let's see, I'm going to try with 4, which doesn't exist. Let's see what happens. See, so it says list index out of range. So the range here in this case is 0, 1, 2, as well as 3. So when I give something as 4 or anything higher than like the number of elements, it throws an error. It says that the list doesn't have that many values. So let's just go back to 3. So that's about the positive indexes. So what if we give a negative value? So this we have seen it in the string as well, like very similar to that. When we give a negative value, what happens is when we give a negative value, it considers the element from the last position. So suppose when I give -1, what happens is it prints the last element of the list. So when I give -2, it would be the second last element of the list. So as you see, the second last element in this case is Tuple. So it prints that value as Tuple. So now moving into an range. So let's say we want to print a range of values. So if I use the negative index, let's say -3, -3 should be Facebook. So this is -1, -2, and -3 is Facebook. So when I specify the first element as -3 and colon, and I don't specify any end element. So what it means is it will print from the minus third element, which is Facebook, until the last element in the list. So let me run this. So as you see here, so minus 3 is the element Facebook. So from minus 3 position, it prints all the way till the end of the list, which is Amazon. So now what happens when I don't pass any values, like any beginning value, but I just pass the end value. So as you see here, what happens is it prints from the beginning of the list, which is Apple, to the minus second position. So the minus 2 should be doodle, but what happens is when you do a range, when you specify the end element, what happens is it prints only till the element just before the element that you mention. So here in this case, what we are doing is we are giving the value is as minus 2. So minus 2 is doodle. So from the beginning of this list, which is here in this case Apple, it goes up to doodle. So it doesn't print this element, whereas it prints only the first two elements like Facebook. So let's say if I am going to give minus 3, so minus 3 would be, sorry, let's say I give minus 1. So minus 1 would be the last element, which is Amazon. So what it should happen is it should print from the first element till the last but one, which is total. So let's see what happens. So as you see here, so it doesn't print the last element. So it prints until the element before the last value that we are specifying. So that's about how to access the various elements in the list based on their index by specifying a particular value or specifying the range of values. So now going further, like a range of values with the positive indexes, like as you see, like similar to what we saw with the negative indexes. So when I say companies 1 to 3, so what happens is it starts with 0. So when I say 1 is Facebook, 3 is Amazon. So of course the last element will not be printed. So it stops the element before the last. So what should happen is it should print Facebook as well as Doodle. Let's see what happens. So as you see here, yeah, it prints Facebook as well as Doodle. What if I pass on an additional parameter? So in this case, let's say it prints every element on the list. So let's say I want to print every alternate element. So what I can do is I can pass on an optional parameter, like additional parameter. So here, as you see on the screen, what I am saying is I'm asking to print from 0 till the third position. Also, I'm passing an optional parameter as 2, which means that it prints only every alternate element. So let me execute this and then show you what's happening. So as you see here, what's happening is it prints the first element, which is 0, Apple. It doesn't print the second element because we say 2, so it strips the second element, goes to the third, prints the third element, which is Tuple, and that's it. Like 0, 1, 2 and 3, it stops. Like 3 is Amazon. There is no one more additional element. So if it had one more additional element in it, maybe it would have printed the additional element. So it strips one and then goes on. So these are all the different ways where we can use to access the elements in an list. So now, so we saw like one of the characteristics of list is it is mutable, which means that we can make changes to it. So now how can we add an element to it? So we can add an element to this particular list by using something called as append. So when we say companies, so companies is the name of the list. When we say companies.append, so what it will do is whatever value we pass within the bracket, so those values will be added to that list that we are mentioning here. So now what would happen is we are going to add an element with a value Tesla to the existing list, which is called as companies. So let me run this one. So as you see, the original list had only 4 companies to it. So now what I am doing is I'm added the 5th element Tesla to the existing list. So now append, what happens as you see is append adds an element to the last position. let's say we want to make some changes in between the list. We want to add a specific element at a specific position. So then what we can do is we can use something called as an insert. So here what I'm doing is I'm using the same list companies. I'm using the insert function to add an element which is Microsoft at this second position. So let me run this one. So as you see, what happens is in the original list, the second position was occupied by Tuple. So this is 0, 1 and 2. So second position was occupied by Tuple. Now what I'm doing is I'm inserting a new second element, Microsoft. So as you see here, the rest of the elements have been pushed and the new element is being added to the second position. So that's how we add an element to an list. So we use append to add it to add an element towards the end, and we use insert to make any changes in between the list. And the next functions are like how to remove or delete an item from an list. So what we can use is we can use remove. So this would remove the element called as Tesla. So as you see, once I run it, so previously we had a fifth element called Tesla, but now after using the remove function, what happens is the last element, which is Tesla, has been removed and it is drawn back to the original list. And so now let me just add Tesla twice. So as we know, unlike set, which we will be going through later in tomorrow's session, and list can have duplicate values. So this is sequenced. So what happens is even if we have duplicate values, so for example, I have added Tesla twice. So you can see it is coming up in the list twice. So the index position of each one of them is different. Whereas in set, what happens is set is unordered. So there is no index to it. So what happens is it doesn't allow you to add a duplicate element to it. So when you add something, it checks whether it is existing. If it is existing, it doesn't add it. It doesn't duplicate it. Okay, so now coming back to the deleting functions, like how we can delete. We can of course use delete, like a del is the delete function, and then we can pass the list and the position of the element which needs to be deleted. So here what we are saying is we are saying to delete the fifth element, which is 0, 1, 2, 3, 4, 5. So this value needs to be deleted. So let me delete it and see what happens. So now if you see here, so there had been 2 Teslas and then one at the fifth position is deleted. The other one is still present in the list. And there is one more way to delete an element. So that's called as a pop. So what is the pop function is, by default, if we don't pass any position to it, what happens is it deletes the last element of the list. So as I run this one, so if you see, I say the companies is a list dot pop, and then I don't pass any positions or any index to it. So then what happens is it takes the list and then deletes the last element to it. So now let's say I pass a value to it. I pass 2 as a value to it. So what would happen is it would delete the element that is there in the second position. So as you see, Microsoft was added in the second position. So now that's deleted and the list is now has only 4 elements in it. So these are all the various delete operations. So we can use remove, delete or pop. By default, the pop function would delete the last element of the list, whereas if we pass a specific position, it deletes the element in that specific position. So moving on to the other functions that has been supported. So the next one is copying the list. So we are going to see why do we need to copy and list. So as you see here, there are 2 ways to copy. So one, what I'm doing is I'm passing the companies list to a new variable called as companies1. Second, I'm copying the same list, but what I'm doing is this time I'm using something called as a copy function. There is a difference between these two. So let's see what the difference is. Let me execute this one and let me print both companies 1 and 2. Okay, so now I'm passing the values to companies 1 and companies 2, and I'm going to print the companies 1 and 2. So as you see here, the elements in both the companies 1 as well as companies 2 are exactly same. now I'm going to remove this comment. Now I'm going to check whether companies is same as companies 1 as well as companies is same as companies 2. Let me execute it. So what we see is, it is returning true for the first value, whereas it is returning false for the second value. We can see that both the list is exactly same. So what's the difference is, when we use equal to, so what happens is a new variable is created. It holds the original value, like companies 1 is created, and it holds the values that is present in the list called as companies. But what's happening is, this new variable here is still pointing to the original variable, which is companies. So we haven't created something new, we have just created some kind of a pointer which points to the original list. Whereas in the second case, what we are doing is, we are replicating and then creating a new variable. So the difference is, when I make any changes to the list companies, which is here, companies 1 would automatically change because it is just a pointer which is pointing to the original list, whereas companies 2 will not change because a snapshot has already been taken, and it holds a specific space in the memory which is different from the original list. So it's not just pointing to the original list, it is different from the original list. So it holds a specific space in the memory. So now let's see. What I'm going to do is, I'm going to add an element to the companies list, and then I'm going to see what happens to companies 1 and 2. So as you see here, when I add an element to the companies list here, the companies 1 automatically changed, whereas companies 2 doesn't change. So that's the benefit of using the copy function. So whenever you want to take a snapshot of the original list and hold it somewhere, it's always better to use copy, so that we are not just pointing to the original list, whereas we have a snapshot of the original value at a point in time. So now the next other functions are how to do a concatenation. So for list, concatenation is very simple. We need to use the plus operator. So when we pass two lists with separated by a plus operator, Python understands that what we are trying to do is, we are trying to combine both of them. So I'm creating a third variable called as companies 3, and I'm combining the list companies 1 and 2 and passing it on to this variable. Now let's see what happens. So as you see here, the companies 1 and companies 2 are added and passed on to the variable companies 3, and when we print, we can see all of them together. So now can I add an integer or a string to it? So let's see. So now when I directly try to use the plus operator, which is used commonly to concatenate a different list, when I pass an integer, it doesn't add up. It knows that this value is not a list, so it can't be added. So let's see what happens when I pass a string. So whenever I pass a value within double quotes, it is considered as a string. So still it doesn't work. So what happens is, the plus operator here is used to concatenate only list. So I can of course add an integer or a string value to it, but it needs to be list. So what I'm doing is, I'm just passing a list with both an integer as well as string. So now I'm going to concatenate. So now if you see, it works. So it adds the integer as well as the string to the existing to the list. So that's how we add different list. And of course, like, one of the special characteristics of an list is the sorting capability. So we can sort all the items in the list. So if I use the sorted function, what happens is, it sorts all the values in a particular list. So as you see here, the sorted, like, we have int as well as strings. So the sort is not working here. So when I just use the companies, which has only the string values, so of course you can see all of them is being sorted. So one thing that you need to be careful is, when we use the sort, if the list is holding a combination of values such as strings and numerates, it can't work. So it needs to be all of the elements of the list should be of a specific data type. So that's that's of course one of the limitation. Like it's understandable, like when like a list allows us to pass and set or an dictionary or values also as part of it, so which can't be sorted. So when we want to use sort, we need to ensure that all the elements of the list are of the same data type. And last, how to clear the values of a list. We can use the clear function, so which just clears up the values, but still the list is not being deleted here. So the list still is present, but it doesn't have any value attached to it. So the other operations are when we do a multiplication to a list, what happens is it just copies itself, it just repeats itself. So as you see here, I'm multiplying it by 2. So what happens is the list gets repeated twice. So let's say I want to multiply the elements 3 times. So what happens is it gets repeated 3 times. So it's not trying to multiply like the values by 3. Like even if it holds an integer value, it doesn't multiply each one of them by 3, whereas it just replicates itself by 3. So if we want to multiply the elements of an list, so then there comes something called as an NumPy library. So we need to which we will be going through maybe in next few days. But for now when we use multiplication, it's being treated as a copy, like how many times it needs to be copied. The list needs to be take a copy of itself and attach to it. And we can use something called as min and match to pick up the minimum value as well as maximum value. So if you see here, the min picks up the first value of the list when it is being sorted. So when we use match, it will pick up the last element when it's been sorted. So if you see here, so Amazon comes first when it's sorted, and then Doodle would take the last position when they are sorted. So that's about the list. So we have seen like various operations that can be performed on a list. So list is of course the most common data type that is being used in Python. But of course, like tuple has its own advantages. So tuple is much more faster than an list, and the tuple doesn't allow it to be changed. So whenever we have a list of values that shouldn't be changed, it is always best to define them as a tuple and ensure that the values are not being changed. So now coming to a tuple, like it's very similar to a list. So we can access the element by their position. We are going to quickly see how it is different from a list. So we are going to define a tuple using the normal brackets, whereas list is defined using a square bracket. So the company's underscore tup is being created. The data type, as you see, is tuple. So what I'm going to do is I'm going to try to replace a particular element like what we did for an list. So if you see here, I'm going to print the element based on the position. So maybe before replacing, let's see how the index works. So the index works, we can pick up an element based on their position. So now if I try to change the value of the first element to Microsoft, so this is something that we have done in list. So let's see what happens here when we try to change the element. So as you see, it says tuple object doesn't support item assignment. We can't change the existing tuple object. So that's why it throws up error. Like it still stays same as the original. And let's try to delete an particular element. So as we saw previously, like a tuple doesn't allow us to be changed. Like this should also throw up an error. So as you see, deleting a particular element of a tuple, when we try to delete a particular element of a tuple, it throws up an error. So it doesn't support any deletion. Of course, like if we want to delete the whole tuple object without passing any position, if we use delete and the name of the tuple, it would be deleted, but we can't make any changes to it. We can't remove just a particular element from it. And then next one is like tuple, as we saw in the introduction, tuple can hold any values. Like it can hold an integer, it can hold a string, it can even hold an list as part of it. So when I execute this, so let me just remove this for time being, and as you see here, it can have any value. So I want to pick up a particular value from this tuple. So the third element, which is 0, 1, 2 and 3, which should be Amazon here. So we are able to print it. So when I did pass 4 to it, so what happens is it prints the last element, not the last element, the fourth element, 0, 1, 2, 3 and 4, which is a list from 1 to 4. So these are all some basic functionalities that are performed for an list as well as an tuple. I am also giving few examples for you to try it out. So it would be good if you can try these examples, so it helps you in building up the foundation and getting yourself comfortable with all these data types in Python. So that's about it for today. So what we have seen today is we have covered two data types, list as well as tuple. We have seen various operations on list, and we saw how tuple is different from a list. So coming to the use cases, as I have previously said, so list is most commonly used, whereas we need to make use of tuple whenever we have a list of values that should not be changed and we are going to do a lot of operations, and it would be much more faster to use tuple rather than a list. That's it for today. I hope you learned something new today. If you have any questions, please mention your question in the comment. And if you have learned something new today, please give a thumbs up and subscribe to my channel to get notified about the other videos. And if you think this would be helpful for someone, please share it with them. Thank you. Bye for now. See you tomorrow.